All right, so welcome everybody to the inaugural JavaScript and Oracle Database Office Hours. This is really meant to be a somewhat informal setting where some of the various folks within Oracle can get in touch with the community. The community, of course, can get in touch with us, share with us some of your frustrations or perhaps even some of your successes. So we'll see how that goes today. With us is, of course, myself, Dan McGhan. I'm a developer advocate along with Blaine Carter. We're both developer advocates. I focus more on the JavaScript community specifically. Blaine's more focused on the open source community. We also have Anthony and Chris. Chris and Anthony work directly on the team that is building node-oracledb. So send all of your complaints their way. If there's any bug requests or anything like that, you know who to talk to. And the way I think we'll do this, and this may evolve a little bit as time goes, we'll just sort of see how things go. But I think we'll start with some kind of introductory topic. Actually, I guess it doesn't have to be introductory. Today's is a little bit introductory, but we'll start with a topic on something related to JavaScript and Oracle Database. Talk about that for a few minutes, and then we'll turn things over to Q&A where folks can just ask us anything that you want. So today's topic will be connection management. So we'll start with the very basics. What is a connection? When you're connecting using node-oracledb to an Oracle database, what is actually happening is a few things. First of all, on the Node.js server, there's going to be a client process created to establish the connection. There will also be a server process created on the database server. So we're saying client server here. Really, they're both servers, but in this case, the node server becomes the client of the database. And so we'll have a corresponding server process that handles the client process. And of course, that server process is going to have a database session. So when you think about the server process, there's going to be some memory set aside for that process to work, but also the database session itself will also see some memory allocation necessary. And of course, these two processes need to be connected by some means to communicate. And the way that's typically going to work with node-oracledb is over a TCP/IP connection. So that's what we're talking about when we're talking about a connection. And when you really take a step back and look at some of the options with Oracle Database, it can sometimes be a little overwhelming because there are, of course, lots of options for making these connections. So what I have here is just a really high-level overview to show you that you're facing a few options on the Node.js server side of things, and we'll talk about those, but you're also facing some decisions on the database server side of things. And we see three options there: the dedicated server process, shared server process, and then DRCP, which is just an acronym for database resident connection pooling. To make things a little bit easier, I want to take one of these options off the table. That is the one there in the middle on the right, shared server process. This is really, you can think of it almost as a legacy connection pooling mechanism. My recommendation, just forget it exists unless you really needed it. As I said, it's somewhat legacy. There are some scenarios that may require it. I believe they're mostly related to Java connections. I don't think they so much apply to the Node.js server world. I recommend you favor DRCP instead. So just keep that in mind. One less server. Chris, do you have something to say on that?
Can I just jump in there? Yeah, it really actually is a hierarchy in terms of memory usage. You would probably look at that shared servers, which is now disappeared off the screen, if you were running out of memory on that database server side. And if that wasn't enough for you, then you would jump to DRCP. So it's more of a kind of hierarchy there that we like to head people towards. There are certainly overheads in using any kind of pooling scenario because you've got to have pool management, and it's a shared resource, so you may run out of it if you don't size it and all that sort of stuff. So you want to sort of work your way through the hierarchy of what works for you on your site.
And which did you say was the best then?
Well, there's no best because it's best is what works for you. If you've got lots and lots of memory on that machine, as most people have nowadays, you would just go with a dedicated server process, which people probably just use and don't even realize they're using. It's the default. And it's only when you start having memory pressures on that database server, because you've got so many connections coming into that machine, and they each need some memory allocated on that database server, that then you would start looking at how you can share those resources into some kind of either the shared server process model or this resident connection pooling. And they have pros and cons and how they work and things like that. So there are the options there, as you suggest. But as I say, it's more of a hierarchy rather than just sort of go straight to DRCP.
Gotcha. This is a good time for me to do something. I'm going to share my entire screen briefly here. Let's see. Top one. And the reason I want to do this is to take us over to, this is the landing page that I believe everyone used just a moment ago to launch the Zoom session that we're currently in. And if you scroll down to the bottom, you'll see I've added 2 links for some resources. The first of which is a link I wanted to point out. This takes you into the Database Administrator's Guide, specifically to the section on managing processes. So if you're interested in learning more about the differences between dedicated and shared server, and then of course about database resident connection pooling, you can just skip to this section of the doc. What I really like about it is this section right here, 5.2.1, which has sort of the side-by-side, and you can see the differences between them. And perhaps most important and relevant to folks here will be this section here that gives a somewhat fictitious scenario, but just so you can see these memory sizing adjustments that Chris is referring to. You know, if you're, for example, if you have 5,000 connections you need to scale and you're just doing dedicated server and you have each session taking about 4,000 KB of memory in the process itself, 4 megabytes, then you're going to face about 22 gigabytes of memory utilization. Once you go to shared server, then you have the 5,000 connections. They each need their session data, but you truly only have 100 processes at 4 megabytes each, so you can reduce that down quite a bit, down to 2.5, and you can see DRCP does even better, taking it down to 6.15. I believe that's the hierarchy you're pointing out. Is that correct?
Yeah, that's right. And just to reiterate, if you go back to your diagram, that's on the database service side. And yeah, that's, as you were just heading towards, kind of almost independent of what happens on the node-oracledb side.
All right, thank you, sir. Okay, so let's get into the database driver. So we have here just a high-level overview of the various classes that you can utilize when working with Node-oracledb. And the base class here is the one we'll focus on. The base class is generally only used to do one of 2 things. It's either going to, A, create what we call a one-off connection to the database. And these types of connections are fine when you're doing things such as a script that maybe runs periodically, perhaps via some cron job or something like that. It can establish a one-off connection. It can do what it needs to do, and then the script is done. It doesn't need to run again for a while, maybe hourly or something like that. But when you're doing what we tend to do with Node, which is often create web servers, maybe APIs, things of this sort, this is what Node does very well. We highly recommend you create a connection pool and then obtain your connections directly from the pool. And the reason for this ultimately is that when you create these one-off connections, the work that goes into creating the process and setting aside the memory that the process needs, there's some overhead with that. When you create a connection
that's
pool,
the database. That's a process on the database side.
Right.
Yep.
When you create the connection pool, you can do that work ahead of time and then simply grab the connection right out of the pool and release it back to the pool and sort of get around some of that overhead, not 100%, but it reduces the majority of it. The only, depending of course on the pooling scenario, but with the pool, that's the inbuilt pool, you're just releasing it back to the pool. So I believe it clears out some state related to the connection. Here's an example of creating a one-off connection. Assuming we've installed the Oracle Database Driver via NPM, we can then just require it into our application. We can then call the get connection method from the base class. And the first parameter here that we're passing in is, of course, the information necessary to get connected to the database. So we have the user and the password information. I'm showing password here in clear text. You probably do not want to do that in your applications. It's probably going to be best to use either an environment variable and refer to that. That's one way to get around it. But we have some other options as well, such as LDAP. And what are some of the others, Chris?
External authentication is
External
the way to go. So
authentication.
there's an
Oracle
extra
Wallet.
attribute.
What was that, Anthony?
Oracle Wallet.
Oracle Wallet?
Yeah.
Okay.
Yeah, so the external authentication can use a wallet or some other method such as LDAP.
Yeah, we should definitely cover that in an upcoming session. Folks, if as we're going here, you have any comments, if for example, that's a topic that interests you, feel free to let us know via chat. I'd be curious to hear if that's important to anyone here.
Yeah, for people not familiar with Zoom, there is a chat icon somewhere on the desktop, little speech bubble. You can just type in there and send group messages or individual one-on-one messages.
You know what, now that you mention it, I am not seeing it.
That's fine, we'll forward you anything you need to know.
That sounds good, thanks. All right, so we pass in the information necessary to get connected, including the connection string here. And what I want to do very briefly is take you back over to those links and point you to the second link. So this is a link going into the documentation for the driver and jumping you to a specific part that covers connection handling. So you can see some of the basics with respect to getting connected to the database. But the part I want to point out now is this section here on connection strings. So the example that I'm using is what we call the Easy Connect syntax. And you can see how that works here. Of course, if you're more familiar with using net service names, there's some doc on how you could do that, where rather than in an Easy Connect string, you're just going to pass in the service name. And then, of course, you'd need to have a corresponding tnestnames.ora file with you know, a name that maps to that service name with the connect details specified there instead. So various ways you can do this, including embedding, which I saw this in a question asked recently. Well, I didn't even know you could do that, so I was happy to find that in the doc. But yeah,
it actually seems to be very common for people to do that for various reasons. And the most common reason is that Oracle has this method. In fact, if you just leave the screen as it is at the top, you can see the two examples. One says service name, and the difference between that and the second example is the other one that says SID. So SID is a kind of old school system identifier. You know, that's the database I'm going to. Service name is like another layer of abstraction. You can have, you know, services speaking to databases, and that Easy Connect connection string only handles service names, not SID. So we often see that full embedded connect string down there in 813 for people who have SIDs and they need to hard code it. They don't want to have any kind of configuration file. There, I think I show service names. I'm trying to use the latest, greatest, but people would often have a SID there, and that's where I typically see it. And of course, it just carries on. Once people start one way, then they just use it forever and a day.
I suppose if you're getting technical too, it also allows you to specify if you want that shared server model or the dedicated connection that we were talking about on the database side of things as well. So
sure, yeah. Easy Connect syntax allows that as well.
Oh,
there's certainly a lot more options there in that full bracketed syntax.
Yep, I've never done that before. All right, so just wanted to point that out. Come back here. So that's all I'm passing in here to get connection. The second parameter is, of course, the callback function. We all know that Node.js is asynchronous, and we use callback functions a lot. The standard or canonical callback pattern means it's gonna be the last parameter passed into an async API like get connection, and then the first parameter of the callback function will be reserved for errors, and the second parameter will be assuming success of the API. We'll get the connection in this case that we're looking for. So the first thing we need to do is check that error parameter to see if it has a value. If so, we can assume that get connection has failed. Perhaps the SID was wrong or the password was wrong, something along those lines. And then we can look at the error to get some information about what went wrong. If there is no error, then you can assume that everything was successful and you can begin to use the connection as you would normally. And finally, when you're done using it, you just want to invoke the close method, and we have a callback function there as well, and you can check that for errors. So using a connection pool, as I mentioned, this is what we really recommend folks do. Same parameters going in for the most part, but you see a few new properties here for pool min and max. we're passing, in this case, pool max and pool min as well as pool increment. And if you notice what I'm doing here, my pool min and pool max, these are fixed numbers and the pool increment is set to 0. This is going to create a connection pool of a fixed size. And correct me if I'm wrong, Chris, I think I learned this from you, but I believe our performance group recommends a fixed pool size over a varying pool size because it just sort of takes the overhead of managing sort of scaling up and down the pool out of the equation. Is that correct?
Yeah, so this is our real world performance group, and this is part of the doc. If you go to the Node doc, if users go to the Node doc, they'll see links to their discussion in our Oracle official documentation. And they've kind of found that the moment that you actually need to increase a pool, if say the max and min are not the same, if you start small and allow it to grow and shrink, the moment it needs to grow is exactly when the machine's under most load, and things start going wrong then. So they prefer sizing machine to cope with a specific load, getting your applications tuned for that load, and leaving it like that. Of course, those parameters are there for a reason. You might have 2 applications on the machine, and you may want one to shrink and grow because they may be used at different times of the day or something like that. So it's certainly user choice, and you need to do some tuning. But their sort of gut feel is that, hey, machine has a fixed number of resources. I'm speaking about the database side. Database has a finite number of resources. We size the pool for the available resources, and we just leave it at that.
And are we able to put a link to that up in the resources as well? We'll just add a new one maybe after the call.
It's in there in the pool tuning in the node-oracledb doc.
In the doc. Okay, yeah, great. So excellent. I believe the other note, if I remember correctly, reading from that, when it comes to the number of connections, they recommend somewhere between 1 to 7 connections per core. So that's another thing.
They have something complex. Again, that's on the database side. They're all database tuning, which is one half of the pipe. So yeah, they got something complex there, and I'm sure that changes with versions and hardware and all sorts of things. So yeah, exactly. Keep up to date with what they're doing.
Right. All right, and then below that, you'll see, again, another callback. So that's the second parameter here. We're checking for errors. If we don't have an error, we can assume we have a pool, and then we can use the get connection method from the pool to then get our connections and use them as we would normally before. The big difference being that close then, rather than actually closing the connection, simply releases the connection back to the pool. We used to have different names for that, but I think we eventually settled on close for similar APIs like that.
So can I speak about 2 things there? I forget
Sure.
now, having looked at your slide yesterday, so you might want to pop that back up again. So,
oh yeah.
So you spoke a little bit earlier about what sort of state is retained across those releases, and if you go back that slide, and then also, do you want to emphasize the importance of calling close and what happens if you don't call close? Are you covering that, or?
I'm not really sure.
Okay, doesn't matter. I'll just mention it quickly. Obviously, it's a shared pool. If you don't release that resource back to the pool when you finish with it, nobody else can use it. End of story. And then, as more and more requests come in from your users to the Node application, and they want to get a connection with the pool, there's nothing for them to use. So you've really got to close those connections. And then obviously do that as soon as possible. If you're going to do non-database work, you may as well just close it so that people who are doing database work can use those resources. And the other thing is, you mentioned briefly state, what sort of state is retained. So Oracle has this kind of concept of sessions and connections, which I don't really want to get into. But we do a rollback once you do that close. But anything which is like an alter session statement, sort of character sets, date formats, that kind of stuff, some PL SQL global state and things like that will still be retained in that connection in the pool. So the next person who gets it out will actually get that state. So pros and cons means for most apps, they don't have to redo stuff because that state is generally common for the whole app. But if you get the wrong state, if you get a new connection which doesn't have that state, you've got to recreate it.
Got it. Thanks. Did somebody have a question or a comment? Thought I might have heard something. Probably just going crazy. All right, so what I'll just show you really quick is really a side-by-side comparison of pool versus no pool. So this is a really simple demo where I'm not using a connection pool. And I should point out, I'm using the newer syntax for working with asynchronous APIs, async await, or asynchronous functions. But you see, I'm bringing in my database driver and then my configuration information from a separate file. And I create a function called run test, and I simply invoke that function at the bottom. And what's happening within that function, I declare a variable to hold the start time before my test runs. The test itself is a simple iteration going through about 100 iterations of a loop. And all I'm doing is going to that base class we talked about, calling get connection. So I'm getting a one-off connection here. And then I'm closing that connection afterward. We're actually closing that physically. At the end of the loop, I then come down and record out the total time that it took to run that test. So we'll run that. Again, this is just 100 times. Took about 5 seconds. Do it again.
While you're doing that, I'll just point out your config is really just your username, password, and the connect string for people who are wondering what's in the config.
We can cat that out as well. So this is the contents of the configuration. So because I was calling the base class, it was ignoring these properties here. So that took, oops, didn't mean to run that.
I'm going to show that.
Yeah. Looks like I broke something.
Hit Control-C again. Oh, nice.
Node's got this kind of loop where it seems to resignal signals, and then we're trying to catch signals, and it's recycling signals, and it's something Node-ish, which we've looked at. And there seems to be a Mac issue, especially if you're using a database inside a VirtualBox machine as well on Mac.
Make that a little bigger again there.
Yeah, thanks. All right, so this is the second test. Hopefully it runs this time, but I'm bringing in the driver, bringing in the config just like before. The main difference is around the run test itself. So now what you see I'm doing is I'm declaring a new variable to hold a pool. So I call create pool, pass in that config, and I get the pool out. Then I start the timer and go into the exact same iteration. The only thing that really changed in the iteration is rather than go to the base class to get the connection, I can go to the pool. And of course, we know that when we call close on a connection that comes from a pool, it's not really going to close that connection physically, but rather just release it back to the pool.
So one thing which you're not doing there is actually counting the cost of creating the pool. And yeah, that is going to take some time, just for people who wonder about that. I mean, the configuration Dan's got is 20 connections. So that will take time to create those 20 processes on the database tier, et cetera, et cetera. So
fair enough. Yes, I purposefully left that out.
Sure. We count it as a fixed startup cost, which apps need to do. And once you're in a steady state, then you'll see exactly what you're about to show, how fast it is.
I think for myself, I tend to move that to a separate file, generally in the main file when I'm starting up my node process. So I tend not to think of it as I would, the rest of the application and how it's going to perform there going forward. That's why I left that out. But as you can see, it's a huge difference between the two, with the pool taking less than 1/10 of a second and without taking about 4 to 5 seconds. So huge difference in performance between the two.
What about the pool cache? Are you going to demonstrate that demo as well?
I'm not sure if I have a demo of that. I believe I do have a slide. So a couple of notes on pools. First thing I'll point out is that we have a queue on the get connection call. It's enabled by default. You don't have to do any work for it, but it's there just to help you avoid any kind of polling. So let's say you create a connection pool with 10 connections and they're all in use, and you call get connection and you want that 11th connection. Well, obviously that's above the pool max. You can't have a connection. So what will happen, your request will get queued, and then once another connection is released back to the pool, we'll go ahead and finish your connection request and pass you back the new connection. There is a timer on that. It'll wait for, I believe, 60 seconds by default, and that is adjustable if you want to either adjust that up, dial it down, or disable it entirely. Another thing to point out, and I only show this because I saw an example somewhere where somebody was basically, when their application was starting up, on the good side, they created a connection pool, but what they were doing is sort of taking the connections out of the pool and leaving them out and trying to service incoming HTTP requests with the same connection over and over. So generally speaking, the way you ought to think about it is only keep the connection out for as brief a time as possible. And generally, you can think in terms of a user request or a database transaction. And once you're done with that, go ahead and release that back for others to make use of. And finally, as Anthony was pointing out, we also have a built-in connection pool cache. And the reason for this, as I was saying before, I tend to create my pools in a main file, or the main.js, which you can see here. So you can imagine if you're creating a pool, and when you call create pool, you're given a pool. If you created a pool in a main file, the question becomes if you want to use that pool in, say, an employees.js file or a departments.js file, how do you get access to the pool that you created in a separate file? And so in the beginning, you had to do a little extra work for that, and we just cut out the work. So now we have a built-in pool cache, and you can leverage that instead. And the way that it works, when you create the very first pool, we're going to go ahead and make that the default. So here's an example of creating a pool in a main.js, where you can see I'm creating the pool here. And note that I don't even save a reference to the pool because it's almost irrelevant. I'm not going to use the pool here. I'm simply creating the pool here and then calling show employees, which is defined here in employees.js. So this module then can bring in the Oracle Database driver as well and simply call get connection off the base class. Now, there's a big difference between this call to get connection and the call to get connection from the base class that you saw previously, and that is that I'm not passing any connect info in here. And when you don't pass a parameter to Oracle DB get connection, it assumes you want to get that connection from this default pool that we're going to create for you. So it goes ahead and does that, retrieves the connection, and then you can use it as you normally would to execute your code.
So the pool has to be created first, right?
That's correct, yes. So this await here, again, I'm using async await. This await operation, which is an asynchronous operation, will complete prior to us going to the next line here, where we invoke the show employees API. But that's a fair point. That does have to finish before it's going to be made available. Now, in certain situations, you may find you have an application where you're connecting with more than a single user. And to do that now, what you would need to do is create multiple connection pools. So we have support for that. When you create a pool, in addition to the common attributes such as pool min and pool max, pool increment, we also have a pool alias property that you can specify. In this case, you see a human resources pool. And if you do that, then you can refer to the pool by name when you're later saying Oracle DB get connection. If you pass in a string rather than an object, we assume that string to be the name of the pool from which you want the connection. So it'll go ahead and get the connection from that pool. Somebody did, however, put in a really interesting request recently in GitHub for, I believe it's an OCI user attribute, where you're saying, I want to get a connection from a pool, but you're actually specifying the pool name. I'm sorry, the username.
Oh, the proxy user.
Proxy, yeah.
Yeah, that's a little different. That's when you acquire the connection. Then you go ahead and specify a username at that point.
Right, right. So I thought that was a pretty cool request. I'm looking forward to something like that landing.
And Anthony was hassling me about it yesterday and trying to work out what the design would look like. So
yeah, I'd love to see that when you guys have something together. All right, so that's it on the connection pool cache. We'd be remiss if we didn't talk at least a little bit about how async works in Node.js and how that kind of relates to what you're doing with async work in general, but more specifically, I think it matters more with the driver and getting and using connections. So Node's often described as this single-threaded environment, and that's true and not true. It's not the complete story. So as JavaScript developers, we're writing application code that is in fact always going to run in what's referred to as the main thread. But as that code is running, we're making different API calls, and some of those calls are considered async API calls. And a good example of that would be right here, get connection. Get connection, followed by execute, followed by close. All three of these are examples of async API calls. Now, when you make an async API call in Node.js, it's going to fall into one of two buckets. It's either going to be completely evented, or it's going to leverage what we call the thread pool. Now, if it's completely evented, this is really the sweet spot of Node.js. Things like timers, which aren't that sophisticated, but also TCP and UDP. TCP does include HTTP, so all the networking types of things, web servers you're doing within Node.js, they're completely evented, meaning that it doesn't require a background thread or process to handle that and see the request through. It can leverage lower level operating system APIs. For example, in this case, poll network sockets to see if there's incoming data or outgoing things. So very, very efficient. On the other hand, certain types of APIs, such as reading and writing files, even DNS, which surprised me, as well as user code, require a thread pool. And they don't talk a lot about this, but Node does have a thread pool. And this user code here is sort of a really big, all-encompassing bucket. And that includes a lot of the APIs that the Node.js driver is using. So the thread pool will be utilized for all of those calls. And whether it was evented or thread pool, when you call these types of APIs, you actually can't see it here when I'm using async await, but when you're calling these types of APIs using the syntax from before, this syntax, the callback syntax, you're passing that callback function when you make the call to the API. So when that API is finished doing its work, the callback function is going to be placed on the event or callback queue, and eventually your JavaScript function will end up back on the main thread and a new call stack. So that's sort of Node.js in a nutshell and how it's doing async work. But what they don't tell you is that the default number of threads in the pool is limited to 4. And so if you're creating a thread or a connection pool rather with the driver with 20 or 60 or 100 connections, but you leave the default size of the thread pool, then in truth, only 4 of your connections are going to be able to work concurrently. So if you want to allow more connections to work at the same time, then you're going to need to bump that up. And so the way you do that is with an environment variable uv_threadpool_size. And you can bump this up. I would recommend going slightly above your pool max, but really your mileage will vary. You kind of have to test this out and see what's best for your environment. Just keep in mind the maximum value is 128. So if you need to go beyond that, you're going to have to spawn new Node.js processes, and best if that's done on different servers. So here's a couple different ways you can set that environment variable. One of the most common is simply setting the environment variable prior to running your Node.js application. Most folks are familiar with this means of working with environment variables. Another way you can do it is from within the application. So here I'm bringing in the Node.js driver and some other modules. And then you see on line 7 here, I'm setting UV thread pool size equal to a higher value than the default. If you're going to use the syntax on the right inside the application, you have to be really careful that you do this prior to invoking any async operation. Because when the very first async operation is run and that thread pool is created, it's then a fixed size. So for example, if start app was moved up to say line 4, or if when I was requiring in any other external modules, they made an async API call such as writing to a file, then it's going to be a fixed size. So keep that in mind. This has to be done very early. This way is just guaranteed and probably the best way to go, but you can use the one on the right when you don't have access to environment variables.
The trouble with the one on the right is you don't get any errors, and it's really hard to work out actually what thread pool size was created until you start seeing deadlocks and slow performance.
Ah, good point. All right, so that's all I have for today on connections. I definitely want to touch on encrypting network connections. This is a topic that is important to me. As we all know, security is more important today than ever. And it's super easy to do with node-oracledb. And so I hope we can tackle that in the future. The next office hour session we'll be doing on Tuesday, March 6th. That's going to be, this is incorrect, UTC, quick time conversion. That'll be at 3 p.m. US Eastern, but 2000 hours UTC. And the topic, not exactly sure what we'll cover yet. Maybe the network encryption, maybe bulk binds, which I think are really important with Node, or something else that you might be interested in. We're certainly open to suggestions. So if there's a topic you're interested in, feel free to let us know and we can talk.
So just since network encryption is pretty important, I just want to point out there is some discussion of that in the node-oracledb documentation. So go and check that out.
And you have a whole section on it here.
Yep. Perhaps the only other thing from this set of slides, which should look really great, Dan, is maybe just to loop back to one of those early slides which showed that mid-tier and the database side, the three different models, and try and connect those bits that we've talked about together. So we started off talking about the database server side very, very briefly, about this sort of hierarchy of memory usage from the dedicated server process to the sort of more shared pooled model on the right-hand side in terms of what happens in database server memory, because you need some kind of process there to handle each connection from your application. And then we really covered mostly discussions on the left-hand side of the connection pool as the recommended solution. So you can actually mix and match those left and right-hand sides together. You can have connection pools with database resident connection pooling if you want. In fact, you want an application to have both dedicated and DRCP at the same time if you really want. I mean, they have both different kind of use cases there,
yep.
Which is covered in the documentation. But really, from the application point of view, use a connection pool, and that's a shared resource on the Node.js server side. If you can think of it, there'd be lots of little arrows. In Dan's examples, he was using a connection pool of size 20, so there'd be 20 little arrows going across to the right-hand side, the database server side. And then how those get handled on the database server side would be determined by the process model on the right-hand side, dedicated, shared, or the resident connection pooling. And that's something bigger picture for larger sites with larger loads and a number of what we would call the mid-tiers. If you've got a number of mid-tier servers, Node.js servers, you might actually definitely look at DRCP as a way to handle all of those connections coming in from the left-hand side to the right-hand side. So there's a little bit of mixing and matching going on, and obviously pooling is good, but as I mentioned, it does take a little bit of overhead sometimes, and you need to be aware of management issues, starting, stopping, sharing resources, and things like that. So hopefully this session has given people a little bit of an insight into what they should be looking at doing.
Cool. Well, if no one has any questions, I have 3:59, so I think we'll go ahead and wrap it up. Just want to say thanks again to everybody for joining us, and hopefully you'll join us again next month. That's going to be, again, March 6th, Tuesday, March 6th. If you have a topic you'd like us to cover, feel free to reach out to us and let us know. Otherwise, we'll pick one within the next week or so. We'll update the information online so you can see that, and we hope to see you at the next office hours. Thanks again, everyone.